Now, one more thing, or the final thing I will say about those three tools, which this video will probably not be watched by a lot of people, but I'm going to make it anyway. One thing that a decent file recovery tool should offer, I think, is a disk imaging option. If you're not strictly looking to recover some deleted files or files from a reformatted partition or a deleted partition or something like that, then if we consider drives or file systems that suddenly just become corrupted, or Windows often shows it as a raw file system. If that happens out of the blue, then it could be a purely logical issue, some file system corruption, and then that prevents Windows from determining the file system. But often, is my experience and experience of peers, often this is related to stuff like bad sectors. And bad sectors are bad because, first of all, we cannot read what's inside the sector. Second of all, is often you don't have just one or two bad sectors. One or two bad sectors is not the end of the world. But if a drive is degrading, often you see groups of bad sectors and these groups of bad sectors growing, and they're becoming more groups of bad sectors, etc. So a drive is, once it starts deteriorating, it tends to continue doing that. And dealing with those bad sectors and scanning for file system structures and lost files and all that at the same time is a bad idea. So this is why I and many others who do data recovery for a living say with such drives, there's basically no other option than first creating a disk image or a disk clone. And since what I've just told you, the deteriorating drives continue to deteriorate, the tool needs some intelligence for dealing with such drives. And this is where this drill really doesn't come close to being useful. It offers a byte-to-byte backup feature, which is good, but it's nothing more than basically a forensic type of thing. So it kind of guarantees that every sector that is on the drive goes to the disk image file, as long as the drive behaves and does not have bad sectors and stuff. In case the drive does have bad sectors, I'm sure it will do something to be able to continue anyway, if possible. But it does not offer us anything to configure that. We can basically name the file, we can tell it what kind of disk image it's going to be. I'm assuming the DMG option is a sector by sector disk image, but DMG, as far as I know, can also mean that the contents of the file are compressed, for example. But I don't know what it does, but I'm assuming it will make a sector by sector disk image that can be used with other tools as well, like DMDE or UFS. I'm assuming that. And by the way, in any case, UFS can also work with the DMG files, but not every file recovery tool can. So bad sectors, yeah, the what I said earlier, a bad sector is a sector that cannot be read, uh, which in itself is not a huge problem if it's one sector or even 10 or maybe even 100. It doesn't really matter that much. But the thing we said earlier is they tend to group together, and the number of bad sectors tends to grow. And so just skipping a bad sector often is not enough. If we skip a bad sector and we immediately run into the next bad sector, then the disk imaging process will become really slow. And if then the next bad sector is also bad, and the next is also bad, this is not what we want. We do not want to read all those bad sectors. And since bad sectors often tend to group together, we basically want to be able to skip a bunch of sectors as soon as we hit a bad sector. That is one thing. The other thing is that if we try to read a bad sector, disk drill is basically not reading a drive itself. It's asking Windows, I want to read from that drive that sector. And so the entire reading and the handling of bad sectors is left to Windows. And I do not recall the exact number, but as soon as Windows finds a bad sector, it will follow a certain protocol. It will try to reread, and it will try to reread again. It will try to reread again. I think it's 8 times, but I'm not sure about that. I would have to look that up. In turn, Windows may be rereading an X number of times, but with each read, the drive itself, when it hits a bad sector, will also start running all kind of protocols to try to recover the data from that bad sector. It probably will reread many more times than the 8 times Windows does. So each read this drill does will and happens to be a bad sector will make Windows retry that sector, and in turn will the drive make retry that bad sector many times. And if we stumble from one bad sector to the other, this will slow down the process, but also it also puts stress on the drive, which we want to avoid if the drive is really deteriorating. So if you ever happen to run into a drive with bad sectors, and this drill, because it does at some point, then prompt you, okay, this is not a good idea to keep scanning this thing, you must make a disk image or a byte-to-byte disk image or whatever it calls it. It's probably better to cancel out of it entirely and get some other tool to make the disk image. And whether this is DMDE or UFS does not really matter a lot, I think. But both tools offer more in this area. I already mentioned skipping. So if we, for example, look at the options that disk drill and this is not what I want. Oh, this is already the disk image that was done. So these are the dialogues that for creating disk images in DMDE and UFS, and we already see we have a lot more options. We can, for example, define the block size. So do we want to read one sector at a time, or do we want to read a bunch of sectors at a time? And probably this drill is reading a bunch of sectors at a time as well, but we cannot change that. It may be sometimes useful to make the number smaller or larger. But this is a minor thing, but can be important. What both these tools offer is the direction in which you want to create an image file. If you have a drive with, and this is not uncommon, with loads of bad sectors at the start of the drive, and so the disk image process is constantly stalling, then it may be a good idea to clone the drive in the opposite direction. So then that way you get the bulk of the data before you get to the hard part of the drive. So this is one tool, that allows you sometimes to clone or image a drive that will not clone when you go in the usual direction. The thing I said about retries, I don't know if disk drill does retries, and if so, how many. Usually I'd say you want to leave that 0, but there are conditions where a couple of retries actually do work. And so that's a nice option to have. And basically each drive is an individual case, and you fiddle a little with it, and you may notice, hey, one retry does the job. The initial read fails, the retry does the job. I have seen this many times with flash drives, for example. So that's a nice option to have. The other thing we see, and we can do the same thing in DMDE. DMDE is not very intuitive when it comes to disk imaging, but the options are there, and once you know your way around it, it's not that hard. But the other thing we discussed earlier is that we're not actually reading the drive ourselves, but it's Windows doing it, and so we have to wait until Windows thinks, okay, now I'm done with it. Both DMDE and UFS offer a more direct access to the hard drive. So this way we can bypass this Windows idea of having to retry a sector this many times. And we see UFS even defaulted, because it detects it is an option in this case, it defaulted to direct SCSI, and in DMDE we can select it. If it's not an option, it's grayed out, so you cannot not make a mistake here. By going through SCSI, we can basically tell how we want to handle I/O errors. We can tell if we want to do retries or not, and we can tell we want to jump over this many sectors. We can do this anyway. This option is always available, even with file I/O. But there's things we can do when going through this interface that we cannot do when we go to this interface, like telling the drive to stop retrying. As I explained before, it's not just us or Windows retrying. The drive internally will retry. This can take 20 seconds. This may seem like a number I pull out of my arse, but it can really take that long. So we can just say, okay, no, we're not going to wait that long. For example, what I talked about earlier with the flash drives, where the first reread actually worked. It has no use, and we, for example, we can do normal reads quicker than one sector. So they basically we're reading the drive, and all the good sectors read in microseconds rather than seconds. We can, for example, put this number to 1, and we can tell it, no, you don't have to wait 5 seconds. If we do not get a read or an error within 1 second, then go do the retry. So I'm not gonna go into everything, but these tools, DMDE, UFS, offer far more precise and powerful disk imaging than this drill. So yeah, I just wanted to show this because I think it's important that file recovery tool offers disk imaging. Well, this drill does, but it's really not very well executed. Just a couple of additions like a skip size, being able to define a number of retries. This alone would be good. That would be gained already. And then I haven't even talked about the multipass imaging that both DMDE and UFS allow you to configure. We talked before about the groups of bad sectors. If we can jump over them until we get a bunch of good sectors, we read the good sectors, we skip over the bad sectors, etc., then at the end of the drive, we will have a number of sectors that have not been imaged, either because they were bad or we skipped over them because at some point you make an assumption. Bad sector skip 128 seconds, for example. It does not mean all those 128 sectors are bad. So this is where multipass imaging comes in. We can say, okay, so we're first going to do all the good sectors, and as soon as we find a bad sector, we skip over a bunch. And then during a second pass, we can go back and retry those that we did not get during the first pass. That's also good. If I mean, I think a skip factor and number of retries is the bare minimum what should be added to this. But yeah, there's lots of room for improvement here. Okay, so this is just basically a quite random overview in 3 too-long videos where I sort of compare 3 tools and show similarities and show differences. And it's not really a review, but there's factors that make one tool really different from the other, and maybe the overall quality is better, but also you need to consider specific scenarios because one tool may be better in one scenario, and like I showed with the MP4 videos in one of the previous videos. Yeah, tools handle situations differently, and sometimes that works out better and allows you to recover data that the other tool does not allow you to recover. Okay, now I'm done talking about these tools for now. Bye bye.